Alright, welcome back, pre-calcers. I haven't filmed a video like this before, so hopefully this doesn't make me go blind and you get all 15 problems on this practice quiz right. So this first problem here has you trying to solve when you're dealing with bases which aren't quite the same yet. You might want to think out your options here. So I personally try to solve problems like this and try to get both sides to have the same base. I try to disregard using log functions. I try to keep it cool, keep it mellow. And so I noticed that both sides have something in common. Most likely you have to think this out. So I noticed the left side has a base of 2 with an exponent of 3x minus 5. The other side's 16. So think out with 16. What would this exponent have to be if you keep a base of 2? What would this exponent have to be to go to 16? We know the other side's 3x minus 5, but what would this other side's exponent have to be for these to be equal? So you should be saying that this has to be equal to 4. 2 to the 4th power equals 16. Since we have the same base, 2 and 2, we can declare that 3x minus 5 equals 4. We can add 5 to both sides. 3x is now equal to 4 and 5, so this is going to give us 9. Dividing by 3 on both sides, 9/3 is going to say that x equals 3. So that's the first answer for the first problem on this pre-calc practice quiz. If you want to, you can go back in and plug in your answer. It's a good way to check your work. So that first answer was that x equals 3. We'll see what's going on with the next problem. If we shimmy on down, we now have still a base of 2, but now we're dealing with a fraction of 1/4. So I'm not going to change up too much here, still keeping our base of 2, but now, since we're dealing with 1/4, what's that new exponent going to have to be? It's tough kind of going here, but yeah. All right, 1/4 is going to have an exponent of -2. We've seen negative exponents before. This exponent here is now 7 minus 3x. Our bases are the same, so now we just focus on exponents. So we have 7 minus 3x. This is now equal to -2. Solve for x. Get rid of 7 on both sides. -3x is now equal to -9. Dividing both sides by what kind of 3 again? It's -3. You know that. X is now going to be equal to +3. One more time, just like Daft Punk. One more time. We have x equals 3. It's all good in the neighborhood. So that's problem 2. Three is pretty easy, but I'm going to skip it. So let's see what's cracking with 4. We have to solve the exponential equation. So we're trying to solve for what x is equal to. In this case, we have e equals 2x power equals 7. We know based off of the natural log properties that if we see a log with base e, this is the same thing as the natural log with x. So once we have this all markered down, don't worry, I got a blue one, we can switch this around because we already know e is here. We can rewrite this and say 2x is now with the natural log. Oh, sorry. So let's rewrite this. So e is your base. It's going to mark over to here. 2x drops down, so you have 2x equals the natural log of 7. Notice I'm using blue. Check it out. Look at me. Look at my shadow. It's pretty cool. So if we're solving for x, divide both sides by 2. This seems kind of a weird answer to have, that x is equal to natural log of 7 over 2, but it totally makes sense. You can hold on to that answer. It's fair game. So we have natural log of 7 over 2. And we're done. And that's what x would have to equal here. So the other problems are similar, relying on natural log properties, taking it further. So let's see what's up with 5. We're now a quarter of the way through. Now a third of the way through, because now we're almost at problem 5, yeah. All right, you know what I mean. You know what I'm talking about, right? So we have a base of 3, 8x is our exponent. The other side's 2.1. Based off of properties of natural logs, I'm allowed to rewrite this 8x towards the front. Let's say this is 8x, multiplying with the natural log of 3. This is supposed to be equal to the natural log of 2.1. So think this out. We're trying to isolate x, seen here. I'm going to get this done in one step because I've got it like that. So think, on the left side, what's not x? What's holding us back? Think about that. So trying to get rid of a natural log of 3. We can divide both sides by that. We can cancel natural log of 3. We can cancel 8. X is left over. This is our answer. Nice little natural log of 2.1 dividing with 8 times the natural log of 3. So this is problem 5. 2.1 all over 8 natural log of 3. So that's problem 5. What's also poppin'? We have different bases, same kind of song and dance. This is falling into the first part of 3.4. So keep in mind, this is the first part of 3.4 where you see different bases. We can go about this same way we did the previous problem. We can take the exponent, x plus 7, rewrite it towards the front. Keep now natural log of 4, and also natural log of 5. Can't hold 5. Yeah, 5. Okay. And so, same kind of song and dance. We're trying to isolate x. You're pretty smart, so you know that these are 2 factors. X plus 7 is 1 factor. And also, natural log of 4 is another factor. So, divide both sides by natural log of 4, keep it moving, see what happens. So natural log of 4 cancels here. Natural log of 4 cancels just on the left side, really. You're now left with x plus 7 equals all of this. Natural log of 4. Deduct 7 on both sides. This is now your answer. You have natural log of 5. Dividing with natural log of 4, and then you're subtracting 7 at the very end. Lots going on here, but you're capable. You got this. Natural log of 5, natural log of 4, minus 7. This is problem 6. See what else is going on here. There's a good amount going on here, but since you're tuning in, you won't see anything like on this on your quiz, so don't worry about this problem. If you're generally interested, this is pretty much the first part of 3.4, just amplified a little bit. So if you want to go back and check out how this is done, check that video. But since you're tuning in, this one skipped, and now you know this because you watched. So don't expect anything like problem 7. If you're generally curious about the answer, let me know. But consider this a bonus because you tuned in, you went the extra mile, you're watching all of this, and 9 minutes in, I don't think you've fallen asleep yet, so that's good. We have seen this kind of problem in the first part, or either the first part or second part of 3-4 part 2, where I said this was really similar to foiling. If you're not convinced, don't believe me, just watch. You can think of this as x squared plus 1x minus 6, but instead of x's, just use e to the x power. So if you were factoring this, you would say that this is x plus 3, x minus 2. We're going to switch it up and now just put in e to the x power. So we can now say e to the x plus 3 multiplying with e to the x minus 2 equals 0. Based off of the zero product property, this is implying that e to the x plus 3 could be equal to 0, or e to the x minus 2 could be equal to 0. Eventually, you can take this further and say that e to the x equals negative 3, or e to the x equals 2. But eventually, you would say that x could be equal to the natural log of negative 3, or x equals the natural log of 2. But keep in mind, the main thing you want to notice here is that you can't have this. It's no good. It's negative. You're better than that. You can't have a negative argument in your natural log. So in reality, we don't want to say this is a good answer. We want to say that just x can be equal to natural log of 2. I don't know what the estimate is, but I think I can get it real quick. So if I was gunning for it, can't quite bring it over. Of course, you'll have a real calculator tomorrow, which is good, so bring that. But if we were going for the natural log of 2, let's see exactly what that is. You would hit 2, hit natural log. It's approximately 0.69. So for 8, approximately 0.69, or just leave the natural log of 2. So that's good. You still with me? You haven't fallen asleep yet? That's ludicrous. I think a good rule of thumb for whenever you watch these videos is to kind of hop around, see what problems you need to take ownership of and look at again. Let's keep it going for 9. I'm going to run through this pretty quickly. We have different bases, so you should be rewriting this as x natural log of 7 equals parentheses x plus 7 natural log of 6. If you distribute to here, this gives you x natural log of 6 plus 7 natural log of 6. Move all of your x terms to one side. We'll soon see why. So rewrite the left side. We'll deduct this x natural log of 6. You may think that you're smart and you just want to rewrite this as natural log of 1, but don't do that. Rewrite the whole thing. Don't get lazy. Write the whole thing. So we're writing x. I'm already going to factor out x because these both have x, so we need to isolate that. So natural log of 7 minus natural log of 6 equals 7 natural log of 6. We can divide both sides by this. Natural log of 7 minus natural log of 6. This is our answer for x. Right there. Pretty crazy. Not the nicest answer in the world, but you're capable. The rest of the quiz starts to tone down in the sense that we're really going to start looking at logs of properties and natural log properties. And those are kind of used together. So here we have base 8 for both of these, so we know we can combine them. We see addition, but when we bring the argument 5 and x together, we want to use multiplication. Keep that base of 8, keep this equal to 1. Go to exponential form, bounce that over. 5x equals 8 to the first power. Solve for x. X equals 8/5. And you're done. So this is for problem 10 or 9, I think. I forget which one. So x equals 8/5. Properties of logs are really going to help you out here. Keep in mind you're trying to move all of your logs to one side when possible. Or to just one log. That's a really important thing to note on here. We see, in this case, we have a lot going on. We now have binomials that we're bringing together. I know we're adding, so we want to use multiplication with our two arguments. So this should be log base 3. I'm going to FOIL this all out. It's x squared minus 10x plus 16. This equals 3. Rewrite it. X squared minus 10x plus 16 equals 3 cubed, which is 27. Subtract 27 on both sides. This is then going to get us negative 9 equals 0. So let's see. We have x squared minus 10x plus 16 equals 27. We've deducted 27 on both sides. My arithmetic is slightly off. If you saw that, kudos to you. So now x squared is going to be minus 10x minus 11. X minus 11, x plus 1 equals 0. The only option that's going to make sense here is when x equals 11. So x equals 11 is good. The other one's extraneous, so x cannot be equal to negative 1. This is extraneous. So you just want to say that x equals 11. The reason why is that we can't have a negative argument or an argument that's equal to 0. So we're just holding on to when x equals 11. 17 minutes in. Let's keep this moving. So we're now dealing with subtraction, which gets a little hairy, but totally capable of it. We are going to be dividing x minus 5, x minus 4. This all equals 1. Going to the normal form gets you 3 to the first power. Multiply both sides with x minus 4. This leaves you with x minus 5 equals 3x minus 12. Two-step equation, minus x plus 12 to the other side. So this is now saying that 7 equals 2x. So x is going to be equal to 7/2. Pretty sure. Yeah, we saw the subtraction at the beginning, so we wanted to use division. X plus 5 is what I should have written, which is a small thing. Maybe you saw it. That doesn't change up the problem too much though, because now the other side's 17. And x plus 5, yeah, 3x minus 12, yeah. Minus that, add 12. All right, so now x equals 17/2. Hopefully you saw that. Would say my bad, but I make mistakes all the time, so if I keep saying that, it just gets repetitive, you know? So x equals 17/2. All right, at the final home stretch, this one's easy. You already have the same base. You already have these logs set equal to each other. So you know that these arguments have to be equal. X squared should be equal to 8x plus 9. Move those all to the same side. Factor it. X minus 9, x plus 1, 0. This is going to claim x could be equal to 9, or x could be equal to negative 1. Let's see, do these both work? I think they will. Yeah, they both work. So both of these are good. Yeah, that's right. X equals 9 or negative 1. If you plug back in and check them, they're both going to work. So that's good. Something you always want to check for. And finally, the last one, we have log. With this, we don't have a base that's written. I'm probably going to skip this one on the quiz, so this is one that's extra. So we're multiplying. We have inside x squared minus x. So I'm distributing ahead of time. Since we see addition, we're using multiplication. This is all equal to log of 6. Since these are now equal, x squared minus x equals 6. Move that to one side. This is now going to be x minus 3. X plus 2 equals 0. X equals 3 or negative 2. So let's check and see if there are any extraneous ones. Well, I know that if x was 3, we can have log 3. That's fine. We can also have log 2. So x equals 3 is definitely good. That being said, if x was negative 2, this would be log of negative 2, which is no good. So this means that negative 2 is extraneous. So this is extraneous. Your main answer should be x equals 3. Hopefully you've enjoyed this video. Hopefully this was insightful to tell you what you need to look at again, what's fair game on the quiz. Hopefully this filtered everything down. If you have any questions, please shoot me an email. Take care. Just need to turn this thing off. Jeez.